Hello everyone, my name is Satyam Maheshwari and today I will explain shortest job first scheduling algorithm and its non-preemptive mode. So what is SGF? SGF is basically a CPU scheduling algorithm in which the process are selected based on their burst time. And by the term non-preemptive, we mean that if the CPU has started the execution of any process, it will complete it first and then only after it will move to the next process. So SJF, it execute the process according to their burst time. And if the burst time of two processes are similar, then FCFA scheduling algorithm is used. And it can be either preemptive or non-preemptive. So today we will discuss only non-preemptive. So what algorithm it follow? It first sort the processes based on their arrival time. Then it sort the process based on their burst time, and after that it will choose the process that has the minimum arrival time and the burst time, and in this way the process get continues. So before moving ahead, we must know some of the key terms that plays a key factor in the scheduling algorithm. First is the arrival time. Arrival time is the time at which the process arrives in the queue. Burst time is the time required for any process to complete its execution. Completion time is the time at which the process has completed its execution. Turnaround time is basically the difference between the completion time and the arrival time. And waiting time is the difference between the turnaround time and burst time. So let's take an example. So we are given with the process ID, arrival time and burst time of 5 processes. And we have to find out the completion time, turnaround time and waiting time. So how we will do that? So first we will prepare the Gantt chart. So as we can see here that the process P4 has the minimum arrival time, that is 0. So it will be the first one to be executed. So therefore in Gantt chart, the first process that arrived is P4. From 0 to 6, it will get executed as the burst time of P4 is 6. Now after that, process P1, P2, P3 and P5 all have arrived in the queue, but the minimum burst time is of P1. So after P4, P1 will get executed for 1 second, as its burst time is 1. So 6 plus 1, 7. So after 7 millisecond, P1 will get completed. Then after P1, the process P3 has the minimum burst time. So after P1, P3 will get executed in 2 milliseconds. So therefore, 7 plus 2 equal to 9 milliseconds. After 9 milliseconds, P3 will get completed. After P3, the P5 will get executed as it is having the minimum burst time. So it required 3 milliseconds. So 9 plus 3, 12. So after 12 milliseconds, the P5 process will get completed. And after that, at last, P2 will get executed in 4 milliseconds. So after 16 milliseconds, P2 will also get completed. So in the here also we have written the completion time, the time at which each and every process has get completed. As we can see that P1 has completed after 7 milliseconds. So we have written over here 7. P2 has completed after 16 milliseconds, so we have written over here 16. And in the similar way for the other processes, we have written. Now to calculate the turnaround time, we will subtract the arrival time from the completion time. So 7 minus 3, that is 4, would be the turnaround time for P1. 16 minus 1, 15 is the turnaround time for P2. 9 minus 4, that is 5, is turnaround time for P3, and 6 minus 0, that is 6, is turnaround time for P4. In the similar way, 12 minus 2 equal to 10 is turnaround time for P5. Now for waiting time, we will subtract turnaround time from the burst time. So 4 minus 1 equal to 3. Waiting time for P1, 15 minus 4, that is 11. Waiting time for P2, 5 minus 2, 3, that is waiting time for P3. 6 minus 6, 0, that is waiting time for P4. And 10 minus 3, that is 7, would be the waiting time for the process P5. Now we will calculate the average turnaround time and average waiting time, which come out to be 8 millisecond and 4.8 millisecond. Now, what are some of the advantage of SGF? That it is frequently used for long-term scheduling, and the shortest time for scheduling reduces the average waiting time. It gives the average waiting time for some specific process, and it is beneficial for the process that is running in batches where the running times are known in advance. For short-term scheduling algorithm, the value of the next burst time needs to be predicted, and the shortest time for scheduling is optional about the average turnaround time. Now, what are the disadvantages of SJF? That SJF may cause starvation if shorter process keeps coming. This problem is solved by aging. It cannot be implemented at the level of short-term CPU scheduling. So this was all about shortest job first scheduling algorithm, in which we sort the process first on the basis of arrival time, then on the basis of burst time, and we select the process that is having the minimum arrival time and minimum burst time. So it reduces the average waiting time. So hence, this was all about non-preemptive shortest of scheduling algorithm. Thank you.